All right, so the first step says line up the variables. So what we're going to do is make sure that the x terms are lined up vertically, and you want to make sure the y terms are lined up vertically. Also notice both of those are in standard form, right? That form ax plus by equals c. So usually when you're in that form, you guys remember this, right? These look like ax plus by equals c. So when the linear equations are in that form, we usually use this elimination method, which again I like to call the addition method. Because what we're going to do here in step 2 is we're going to add the equations together. So we actually want to add these together like this. So what happens when I do that? What cancels out?
I can't see the y's.
Yeah, the y's are eliminated. Do you guys see that? When you add these together, negative 4y plus 4y, that is 0. So then you add 3x plus 1x. So that's 4x. And that would equal 10 plus negative 2. That's 8. You just divide both sides by whatever number's in front of the variable. Those cancel out, make a 1. And you get x equals 2. That's pretty easy, right? Now, you can take x equals 2, and you can plug it into either of the original equations. It doesn't matter. So you could plug the x equals 2, you could plug it in for this x right here, where it says 3 times x, or you could plug it in the bottom one right there. So I think I'm actually going to plug it in the bottom one. So I'm going to take this x equals 2 right here, this thing, and I'm going to put it in for that x right there. Well, if I do that, then that bottom equation is going to say 2 plus 4y equals negative 2. And then I'm just going to solve that equation for y. So I'm going to subtract 2 on both sides. Those cancel out, make 0. The left side is 4y. That's equal to negative 2. Take away 2 more. Good. Then you're going to divide both sides by whatever number is in front of the variable. Those cancel out, make a 1. I get y equals negative 1. Negative 4 divided by 4 is negative 1. And there you go. So you got your x coordinate and your y coordinate. And again, usually in the book, they'll record the answer then as a ordered pair. So they'll do it. X is 2, y is negative 1. Remember, if we graph both of these linear equations, we would find that the two lines hit each other or intersect at this point right here. All right? That's not too bad, right? So again, when these are in standard form, I kind of like this method better. So let's do number 2. So number 2, same thing, right? We are going to add the equations together. What cancels out on this one? The x's. Yeah, well, I should have said we were supposed to make sure that the y terms lined up vertically and the x terms lined up vertically, which they do. Yeah, and then you guys are right. The x's cancel out. 3x minus 3x, that is 0, so those cancel out. So then we just do 1y plus 2y. That's 3y. And that's going to equal negative 2 plus 14. That's 12. Divide both sides by whatever number's in front of the variable. Those cancel out, make a 1, and we get y equals 4. Okay? Now, again, we can plug in y equals 4 into either of the original equations. Doesn't matter which one. So you could plug 4 in for y either right here. Oops. Either right there. Or right here where it says 2 times y. I would probably put it into the top one. So I'm going to take that y equals 4, and I'm going to put it in right there. Let me try that again. Do you guys like when I draw these arrows or no?
Yeah.
All right, so then that one's going to look like 4 plus 3x equals negative 2. Now you got a two-step equation. So you subtract 4 on both sides. Those cancel out and make 0. So on the left-hand side, I got 3x. On the right-hand side, I got negative 2. Take away 4 more. Good. Then divide both sides by whatever number's in front of the variable. Let's cancel out, make 1. I get x equals negative 6 divided by 3 is negative 2. And again, if you want to, then you can report the final answer as an ordered pair. X goes first, so that would be negative 2. Y is second, so it would be comma 4. Now, you could check your answers on these, right? That's the other thing is you guys can, like, if you finish the test or quiz early, we're going to try to we're going to finish 6-4 tomorrow. We're going to try to take a quiz on 6-1 to 6-4 on Monday. All right. You can check your answers on these, right? All you got to do is plug the x and y that you found into both equations and make sure that it makes both equations true at the same time. So just like real quickly here, so if let's say we were going to do this one, we are going to check it in this top one. Well, we would plug in the y, which would be 4, and that would have to equal 3 times, that would be 3 times the x, which was negative 2. And then that should equal negative 2. And that's just a really quick check. What did I do? I messed something up, didn't I?
Yeah.
That's supposed to be a plus in between there, isn't it? Yeah, that's supposed to be a plus right here, right? I went so fast, I messed it up. That's a plus. Yeah, so I'm plugging the 4 in. I'm plugging the 4 in for y right here. And then I'm plugging the negative 2 in for x right there. So this thing says, what does this say? It says 4, well, positive 3 times negative 2, that's a negative 6. So 4 minus 6 equals negative 2. That checks, right? So again, and we could check it in the bottom equation also, but I'm not gonna. But that's how you check your answers. So there's no reason, if you finish the quiz early on Monday, you can check your answers. Oh, I gotta undo all this stuff, hold on. There, okay. Let's go to number 3. So number 3. Now, what's different about number 3? Yeah, Devay? Damien?
When you go to add,
Yeah.
it cancels out.
Yeah, if you add them together like they are right now, nothing cancels out, right? You guys see that? So if we were to add these together right now, well, we would get 2x plus 2x would be 4x, and 1y plus negative 5y would be negative 4y, and that would equal negative 5 plus 13 is 8. Well, that's not going to help you, right? Because we didn't eliminate a variable. So what we need to do is we need to figure out what could we multiply one of these equations through by so that one of the variables will cancel out. So what we're looking for is, like, let's say if we had one where it was like a 7x, you'd want to make sure that the one below it was a negative 7x then, right? Because you want those to cancel out and make 0. So what could we multiply through by? On which equation? Well, actually either one, right? Yeah. Yeah, so you want to multiply one of the equations through by negative 1. And what would cancel out then? The x's, good. So maybe I don't know. I'm going to multiply the top one through, I think. So I'm going to do the top one, I'm going to multiply by negative 1. So negative 1 times that top equation. Now that means you got to multiply everything by negative 1, okay? You're multiplying the left side by negative 1, you're multiplying the right side by negative 1. So you got to multiply the 2x by negative 1, you got to multiply the positive y times negative 1, and you got to do the right-hand side, you got to do negative 5 times negative 1. All right? So if we do that, then that would become, well, basically that's going to change the sign of each of them, right? So that's going to become a negative 2x, a negative y, and a positive 5. You guys okay with that? Again, if you do a negative times a positive, that would be negative. Then you do a negative times a positive y, that would be negative. Then you do a negative 1 times a negative 5, that would be a positive 5. The second equation, we're just going to bring it over like it is. So that's 2x minus 5y equals 13. Now we're going to add the equations together. Again, that's why I call this the addition method. Your book calls it the elimination method. They call it elimination because the x's just canceled out, right? Negative 2x plus 2x, that's 0. It's 0x, but it's still just 0. So then you add the y terms together. So you got a negative 1y, take away 5 more y's. Yep, that's negative 6y, good. And then on the right-hand side, you got 5 plus 13, that's 18. Then you divide both sides by whatever number's in front of the variable. Those cancel out, make a 1. You get y equals 18 divided by negative 6 is negative 3. And then you can put that y wherever you want, okay? You could plug that y equals negative 3. To go back and find x, you could plug the negative 3 into for y right here, or in the first equation, or in the second equation. Doesn't matter. I would probably put it in the top one. So here, let me do this. Let's do a... So I'm going to take negative 3 for y. Let me use a different color. I'm going to take negative 3 for y, and I'm going to put it in right there. So if I do that, then that top equation is going to become 2x plus negative 3 equals negative 5. Well, 2x plus negative 3, that's the same thing as 2x minus 3. So now I got a two-step equation, so I'm going to add 3 on both sides and then divide by 2. So add 3 on the left, add 3 on the right. I get 2x. These cancel out, and it's supposed to be a 3. Those cancel out, make 0. On the right-hand side, I got negative 5 plus 3, that's negative 2. Then I divide both sides by whatever number's in front of the variable. Those cancel out, make a 1. And I get x equals negative 2 divided by positive 2 is a negative 1. And then if you want to be cute, you can report your answer as an ordered pair, negative 1, comma, negative 3. You guys good so far? Okay, let's keep going. So we got to do number 4. So what do you guys want to do with 4? By what? Yeah, same thing. We can use the same idea again, right? So we could multiply either the top equation or the bottom equation by negative 1, and then what would be eliminated? Yeah, the y's would cancel out. So I don't know, I'll just do it the same as the last one. So I'm going to multiply the top through by negative 1. So then that's going to become, everything's just going to change sign. I do negative 1 times 3x, that's going to be negative 3x. Then I do negative 1 times positive 3y, that's going to be a negative 3y. And then, of course, the common mistake is everybody forgets to multiply the right-hand side. You also must do the 15 times negative 1, which is negative 15. And then the second equation, we're just going to rewrite it like it was. So we didn't change anything there. And then we're just going to add them together. So when we add them together, hopefully you can see that the y's are eliminated. Negative 3y plus 3y, that is 0. So then you just got negative 3x, take away 2 more x's. Good. So you got negative 5x's, that's equal to negative 15, take away 5 more. That's negative 20. Good. Then you divide both sides by whatever number's in front of the variable. Those cancel out, and you get x equals negative 20 divided by negative 5 is a positive 4. Again, now you take your x equals positive 4, and you can put it in this equation right here. You can put it in this one. You can put it in the bottom one over here on the left, the second equation, or you can put it in the top one, the first one right there. It doesn't matter. Just so I don't make a big mess here, I'm going to put it in the bottom one of the original 2. So let's do this. So we're going to take that x equals 4, and we're going to put it in right there. So that bottom equation now is going to say negative 2 times 4. So we're replacing the x with the 4. And then plus 3y equals negative 5. And then negative 2 times 4, that's a negative 8. Plus 3y equals negative 5. And then you got a two-step equation. So you're going to add 8 on both sides and then divide by 3 on both sides. So add 8. These cancel out, make 0. So now I got 3y equals 8 minus 5 would be 3. Then divide both sides by whatever number's in front of the variable. Those cancel out, make a 1, and I get y equals 1. And then again, if you guys want to, you can write the ordered pair. So x would be 4 and y would be 1. Remember, if we graph both of those linear functions then, these, we'd find that they had two graphs or the two lines hit each other at that point right there. That's where they intersect or cross. All right, let's do number 5. We're almost there. So 5. Let's see. This one multiplied through by negative 1 is not going to work, right? So we got to figure out what could we multiply through by so that one of the variables is eliminated. Anybody got an idea? Remember, if this one would have if there was a negative 3x here, well, then you would need a positive 3x above it, right? Because you want to add them together and you want them to cancel out. Or if you had a positive 2y here, you'd want a negative 2y below it so that when you add them together, those would cancel out and make 0. So anybody got an idea what to do? Other than Rachel this time. Now, there's a couple tricky ones in the book where you have to multiply both equations through by something. This one right here, you really only need to multiply one equation through by a number. So who's got an idea out there? Adrian, you got an idea? No, it wasn't Aiden. Yeah.
Oh, okay. You can multiply the bottom by negative 2.
Yeah, that'll work good. So we'll multiply the bottom equation through by negative 2. I like that. So let's multiply the bottom equation by negative 2. All right, so if we do that, then this bottom equation is going to become, we're going to distribute the negative 2 on the left. So we're going to do negative 2 times negative 3x. That's going to be a positive 6x. Then we're going to do the negative 2 times the positive y. That's going to give me a negative 2y. And of course, the common mistake, you got to remember to multiply the right-hand side by negative 2. So you got to remember to do the negative 2 times the negative 5. So that would be a positive 10. And then the top equation, we're going to leave it alone. We're just going to bring that one over. So if we bring that one over, that one's just 1x plus 2y equals 11. And then we're going to add these equations together. So hopefully you can see the y's cancel out and they are eliminated. That's 0. Then we got 1x plus 6x, that's 7x. And that is going to equal 11 plus 10 is 21. Then we divide both sides by whatever number's in front of the variable. Those cancel out, make a 1. We get x equals 21 divided by 7, which is 3. All right. Then we can take that x and plug it into any of those 4 equations. Doesn't matter. So I guess I'll probably plug it into this top one right here. So I'm going to plug that x in right there. So maybe I won't draw a big arrow this time. But we've got, let's see, pick another color here. So we've got x equals 3. So I'm going to take the 3 and I'm going to plug it in right there. So then that top equation would become, we'll do it in green. That one would become 3 plus 2y equals 11. So then we got a two-step equation, so we subtract 3 on both sides and divide by 2. Those cancel out, make a 0. On the left-hand side, we just have positive 2y. That's equal to 11, take away 3 is 8. And then divide both sides by whatever number's in front of the variable. Those cancel out, make a 1, and we get y equals 4. 8 divided by 2 is 4. So there's your solution. Your x-coordinate is 3, your y-coordinate is 4. And then if you want to be cute, you can write that as an ordered pair, 3, 4. All right, and then we go to do number 6, which is missing. There is no number 6. Let's see, how long did it take us to get through that much? What time did we start at? We started at 35?
Yeah, we didn't start notes till like 45 minutes.
Okay, so about a half hour, okay.
Yeah.
So 45 minutes from, I'm trying to figure out how this is gonna time out with the lockdown next hour, that's all. So they start at 1:10, and 1:55, that'd be close. All right. All right, let's try to do this story problem. What's up? Yeah. Let's try to do this story problem. Okay, so this story problem is, it's different. Like all the ones we've been doing lately have all been in slope-intercept form. I keep asking you guys what's a slope. So they've all been in the form y equals mx plus b, right? But this one, there is no problem number 6, so this problem number 7. This one, both equations are going to be in standard form. And if you notice, that's kind of what we've been doing, right? Like if you look at this system of equations right here, this one, that's in standard form, right? That's in the form ax plus by equals c. Those are not in slope-intercept form. So let's see if we can set this thing up. So this says Paige she's gonna spend $7.75. She's gonna buy 12 sheets of felt and cardstock. So she's buying sheets of felt and sheets of cardstock. So I don't know what she's doing, but she's making some kind of project or she's doing some kind of craft or something. All right. So, and then it costs 50 cents for each sheet of felt, and it costs 75 cents for each sheet of cardstock. And they want to know how many sheets of each can she buy with $7.75. So what the equations are going to look like here is, we haven't really done one like this. I'm going to, instead of using x and y, I'm going to use f and c, okay? Just because f will stand for the number of sheets of felt and c will stand for the number of sheets of cardstock. So the first equation is going to look like this. It's going to be f plus c equals 12. Maybe how much room do I got here? I got a lot of room. I'm going to write that a little bit smaller. So it's going to be f plus c equals 12. That's my first equation. All right. So again, like the C there, that stands for the number of sheets of cardstock. Okay? And then F, I'm not going to write it out, but F is going to stand for the number of sheets of felt. And then the 12 here, that's the total number of sheets, right? That's the total number of sheets. So really, that first equation is all about the number of sheets of each. The second equation is going to be about money. So what does one sheet of felt cost?
50 cents.
So that's going to be like 50 cents times F. That's going to give you how much you spent on the felt. Plus, how much is it for each sheet of cardstock? So that's going to be 75 cents times the number of sheets of cardstock. So that's going to be the amount of money you spent on cardstock. And that's got to equal the total amount of money that you're spending, which is $7.75. Does that kind of make sense? So that second equation is a money equation. So again, this thing right here, that represents the amount spent on the felt sheets. Okay? The second term there, the 0.75C, that would represent the amount of money spent on the cardstock. And then this number over here on the right, that represents the total amount spent. Okay, but so the first equation is all about sheets, and then sheets plus sheets equals the total sheets. And then the second equation is all about money. It's how much money you spent on each added together to equal a total of $7.75. Okay, so now let's line them up. Let's make them into a system then. So I'm going to come over here, and our system is going to look like F plus C equals 12. And the one below it is going to be 0.50F plus 0.75C. 0.75C equals $7.75. So now I got them lined up. Now if I add them together right now, nothing is going to be eliminated, right? Neither variable. So I got to multiply one of the equations through by something. What do you want to do?
Sorry, -2.
You could do that. What else could you do?
Oh, you could divide this off by negative. It would be -2, right? I don't even.
Just make the numbers line up, right? Like, look at, if I've got a, if I have a 0.50F here, shh, quiet please, then above it I need to have a negative 0.50F, right? Because you want them to cancel out when you add the equations together, right? So what can I multiply the top equation through by then? Yeah, -1/2, right? -0.5 or -0.50. So let's multiply the top one through by -0.50. All right? So let's see if we can get through this. All right, so here we go. So then we're going to multiply through by -0.50. So -0.50 times F would give me -0.50F. And then -0.50 times C would give me -0.50C. And then I'd have to multiply the 12 times -0.5. What's that? That is -6. So that's -6. And then the bottom equation, we're just going to bring it over and leave it like it is. So that's 0.50F plus 0.75C equals $7.75. Now add them together. So hopefully you can see these cancel out now, right? The F's. Ethan, quit with the sound effects. You gotta remember I'm recording here. All right, so then when we add the C's together, what's 0.75C minus 0.50C? Kids? This is like 75 cents minus 50 cents. What's that?
25.
That's 25 cents, right? So 0.75 C's take away negative 0.50 C's. That is going to be a 0.25 C, right? And that's going to equal, what's $7.75 take away $6? Yeah, $1.75, right? So 1.75. Then divide both sides by 0.25. So you divide both sides by whatever number's in front of that variable. Those cancel out, make a 1. I get C equals $1.75 divided by a quarter is, how many times does a quarter go into $1.75? said, seven. I said, how many times does a quarter go into a $1.75? It's 7. So C equals 7. All right, well then, you're buying a total of 12 sheets, right? Look at this first equation back over here. Way over there. This one. Look at this one. C is what? C is 7. So 7 plus what would equal 12? Right? Yeah, it's got to be 5, right? We plugged in, we're going to plug in right here for C, we're going to plug in a 7 right there. All right? So that equation is just going to say F plus 7 equals 12, so F has got to be 5, right? If you're buying 7 sheets of cardstock, you got to be buying 5 sheets of felt if the total number of sheets is going to add up to 12. But I'll write that down over here for you guys. So that's going to say, if we plug that in there, that's going to say F plus whatever C was has to equal 12. Subtract 7 on both sides, we get F equals 5. So this one over here tells us we're buying 7 sheets of cardstock.